Okay, Algebra, welcome back. We are continuing on with factoring. It's just kind of a summary of what we did yesterday and making sure we know what to do given certain types of problems. So we are doing the Unit 10 Day 10 notes, which you can find in your packet, you can find on Canvas, or you can do it on your own paper, whatever you choose. Here's what we've got. We've got these types of problems, all right? If you have something like this, all right, where there's just a 1 in front of the x squared, all right, versus a 4x squared minus 40x plus 96 versus a problem with an equals 0, okay? For these problems, depending on what it is, you're going to do a GCF if possible, all right? So if you have a number other than 1 in front of the x squared, that's going to have a GCF. If it just has a 1 in front of the x squared, there is no GCF. All right, other than 1, which isn't anything big deal. And then after that, then you do a box problem. So the whole multiplies to be this, adds to be that. If it's a number that if it's a problem that equals 0, all right, you want to make sure that it is equal to 0. All right. Second step is you'll do a GCF if possible. All right, so if there's a number other than 1 in front of the x squared, do a GCF. Step 3, you'll do the box problem. Multiplies to be this, adds to be that. And then the final step is you're going to do ZPP and solve. Set things equal to 0 and solve. So those are your steps depending on what kind of problems you have. So let's deal with factor completely. Notice these problems do not say solve. Notice there's no equal sign. Nothing like that. So we're talking about these problems here where you're going to do a GCF if possible and then a box problem, and that's it. So for number 1, if you notice there's a number other than 1 in front of the x squared, so there is a GCF. Usually the GCF is going to be this number right here, and it is. All 3 of those numbers can be divided by 8. X will not be part of the GCF because not all 3 of them have an x. So 8 is my GCF that goes out in front, and all of these are going to be divided by 8. So 8x squared divided by 8 is just x squared, 16x divided by 8 is 2x, and oops, that's a minus. 192 divided by 8 is 24. All right, after that, box problem. So it's got to multiply to be negative 24 and add to be 2. Those numbers are going to be 6 and negative 4. You make 2 sets of parentheses. The 8 is still in front. X goes at the front of both of those parentheses. Positive 6 means plus 6. Negative 4 means a minus 4. And then you're done. We do not do any solving unless there's an equal sign or it says to solve. This is it. We're done after that step. We're going to skip number 2. Let's look at number 3. For number 3, if you notice, there's just a 1 in front of the x cubed. If it's just a 1, a 9, and a 14, if one of these numbers is 1, your GCF number-wise is just going to be 1. So there really isn't a specific number GCF other than 1, which isn't really that important. But if you do notice, all 3 of these do have an x. So x is going to be part of your GCF. You take the smallest one, which would be x to the first. So x is our GCF. If you want to put 1x as the GCF, the 1 is optional, but again, the 1 isn't really important. Since x is our GCF, we're going to divide each of these by x to see what goes inside our parentheses. X cubed divided by x is x squared, minus 9x squared divided by x is 9x. 14x divided by x is 14. The x's cancel. So that's going to be what's inside the parentheses. And then we get to do a box problem. It's got to multiply to be 14 and add to be negative 9. Those numbers are going to be negative 7 and negative 2. You make 2 sets of parentheses with x at the front of both. Our GCF goes out here. Negative 7 means minus 7. Negative 2 means minus 2. And then we are done. It doesn't say to solve. There's no equal sign. So we are good. You don't need to keep going and say x equals anything. All right, let's look at number 4. For number 4, we have 5, 30, and 45. Again, this is more than likely the GCF, which it is. All of those numbers can be divided by 5. So 5 is our GCF. If you notice, they all also have an x. You take the smallest one, which would be x to the first. So 5x is my GCF. To figure out what goes inside these parentheses, I'm going to divide each of these by 5x. So 5x, 5 divided by 5 is 1. You can put the 1 if you want. It's optional. X cubed divided by x is x squared. 30 divided by 5 is 6. X squared divided by x is x. Plus 45 divided by 5 is 9. And the x's cancel out. Now we can do our box problem. So it's got to multiply to be 9 and add to be 6. Those two numbers are 3 and 3. You make two sets of parentheses. The GCF is still out in front. The x goes at the beginning of both of those parentheses. 3 means plus 3, and the other 3 means plus 3. So you're going to end up with 5x times x plus 3 times x plus 3. The other way of writing this would be 5x times x plus 3 quantity squared, since there's two of them. You don't have to write it that way, but I just thought I'd show you both options are totally fine. All right, let's look at number 5. For number 5, you have 5x squared minus 500. All right, if you notice, this is a 5, this is a 500. They're both divisible by 5. So 5 is going to be our GCF. There is no variable as part of our GCF because they both don't have an x. We're going to divide them both by 5 to see what goes inside the parentheses. 5x squared divided by 5 is x squared, minus 500 divided by 5 is 100. This is the same thing as x squared plus 0x minus 100. So we're going to do a box problem with negative 100 and 0. Multiplies to be negative 100, adds to be 0 would be negative 10 and positive 10. So the 5 is going to go out in front. We're going to have two sets of parentheses, x at the beginning of both, and negative 10 means minus 10, positive 10 means plus 10. And then we're all set. All right, number 6 is going back to actually problems that we did at the beginning of this unit. If you notice, 1, 3, and 2, the only number that all three of those can be divided by is 1. And then they don't all have an x in common. So if your GCF is just 1, you don't really need to worry about dividing all of those by 1. We can just go straight to the next step. So the next step is just a box problem. It's got to multiply to be 2 and add to be 3. Those numbers are going to be 2 and 1. So you just make two sets of parentheses. X goes at the front of both. Positive 2 means plus 2. Positive 1 means plus 1. All right, so if it's a GCF of 1, you don't need to worry about dividing by 1. That's kind of silly. And you get that. All right, what I'd like you to do is I'd like you to try number 7 and number 8. All right, give them a try. Remember, you want to do the GCF and then the box problem. So go ahead and try. All right, so looking at number 7, you'll notice that all three of these are divisible by 2, and they all have an x. To take the smallest one, 2x is going to be your GCF. So there's my GCF. I divided each of these by 2x. All right, 2 divided by 2 is 1. X cubed divided by x is x squared. 2 divided by 2 is 1. X squared divided by x is x. 144 divided by 2 is, you still have a minus there, 72, and the x's cancel. Then you do your box problem. It's got to multiply by negative 72, add to be negative 1. You get x minus 9, x plus 8, and the GCF 2x is out in front. Number 8, the GCF for this one is just going to be the 3. All three of those are divisible by 3. They don't all have an x, so x is not part of the GCF this time. I divided all of them by 3. I got x squared minus 6x plus 9. It's got to multiply to be 9, add to be negative 6. Those numbers are negative 3 and negative 3. So I got 3 times x minus 3 times x minus 3. Or you could write 3 times x minus 3 squared. All right, let's look at the back. Okay, the back is a little bit different. Okay, we're going to skip this. We're going to factor completely and then solve. Notice the word solve. Notice there's equal signs in these problems. With these, you're going to first of all make it equal to 0. So if it's not equal to 0, move stuff around. Step 2, you're going to do a GCF if possible. All right, if it's just a 1, that's not really a GCF. All right, step 3, you're going to do a box problem. And the final step is you're going to do ZPP and solve. All right, so let's look at number 10. Number 10, you'll notice it is not equal to 0. It's equal to 9x. So we got to move it. We're going to minus 9x from both sides. When I do that, I'm going to put it in descending order, so I'm going to put the 9x in the middle. So I have x squared minus 9x minus 10 equals 0. From there, GCF if possible. Notice there's just a 1 in front of the x squared. So if there's a 1 in front of the x squared and they don't all have a variable in common, your GCF is just 1 for this problem. And if it's a GCF of 1, it's not really a GCF. So we can move on to step 3. Box problem. All right, box problem. It's got to multiply to be negative 10, add to be negative 9. Those two numbers are going to be negative 10 and 1. You make two sets of parentheses. X goes at the front of both. Negative 10 means minus 10. Positive 1 means plus 1. And then you're going to set things equal to 0. Set x minus 10 equal to 0 and x plus 1 equal to 0. You're going to add 10 to both sides, giving you x equals 10, and subtract 1 from both sides, giving you negative 1. Okay? For number 11, we're going to skip that. Let's go to 12. For number 12, make it equal to 0. Check. All right? Then, if you notice, all three of these, well, first of all, this has a 1, 14, and a 48. Since this has a 1, 1 is technically our GCF. But they also all have an x in common. We're going to take the x that has the smallest exponent, so 1x, or just x, is my GCF. Since x is my GCF, I'm going to divide all of these by x to see what goes inside my parentheses. X cubed divided by x is x squared, minus 14 x squared divided by x is x, and 48x divided by x is 48. From here, what we're going to do is a box problem. It's got to multiply to be 48 and add to be negative 14. Those two numbers are going to be negative 6 and negative 8. So we're going to have two sets of parentheses, GCF's in front, x at the beginning of both. Negative 6 means minus 6, negative 8 means minus 8. And then we're going to set things equal to 0. We can set x equal to 0, we can set x minus 6 equal to 0, and x minus 8 equal to 0. We're going to have three answers: 0, 6, and 8 once you solve it. All right. Number 13, we're going to have 2, 14, and 12. So our GCF is definitely 2. They're all divisible by 2. But they also all have an x. You take the smallest exponent, it would be 2x. So 2x is my GCF. Because 2x is my GCF, I'm going to divide all of those by 2x. This will give me 1x squared. 14 divided by 2 is 7. X squared divided by x is x. 12 divided by 2 is 6. X divided by x cancels. Now we do our box problem. It's got to multiply to be 6 and add to be 7. Those numbers are going to be 6 and 1. So I put the GCF in front, two sets of parentheses with the x at the beginning of both. Positive 6 is a plus 6. Positive 1 is a plus 1. And then you're going to set things equal to 0. You're going to set 2x equal to 0, x plus 6 equal to 0, and x plus 1 equal to 0. You're going to get x equals 0, subtract the 6, you get x equals negative 6, and subtract the 1, you get x equals negative 1. Okay, so that's how those are going to work. I'd like you to try number 14 right up above, or not 14, I apologize. We're not going to do 14 at all. Don't worry about those problems. Try number 11. Okay, you're going to try number 11 real quick and give it a go. So let's see how you did with the last one. You'll notice that all of these are divisible by 4. Also, it's usually just this number right here. They don't all have an x in common, so x is not part of the GCF. But 4 is. I divided each of these by 4. I got x squared. 32 divided by 4, I got negative 8x. And then 48 divided by 4, I got 12. After that, box problem. It's got to multiply by 12, add to be negative 8. You're going to get negative 6 and negative 2. So x minus 6, x minus 2 with the 4 out in front. You cannot set 4 equal to 0. All right, that doesn't work out. But you can set x minus 6 equal to 0 and x minus 2 equal to 0. Solve and you will get 6 and 2 for your answer.